numbers means sorting them into groups that are based on their properties. Let's start with a history lesson. If you imagine a nomadic group of people, they would have needed to count to be sure everyone was present before moving on to a new place, or making sure that they had all their animals. So we assume that counting was essential pretty early in the existence of humans. And we also assume that they began with the number 1. Some cultures only had symbols for 1 and then many, which represented anything bigger than 1. And other cultures obviously counted higher if you look at these bones. Eventually, people had the need of a way to describe nothing, and so 0 was added to the list. We refer to the first list as the counting numbers, and the second list we call whole numbers. The only difference is adding the 0 to the list. Eventually, people developed the need to describe amounts less than 0, and that's where we get our integers from. So you see, we were just expanding the list as time went by. At some point, people noticed that there are amounts between those whole numbers and integers, and we need a name for those. And so they used ratios to show this. That's 1 divided into 2 pieces, and we call that 1/2. These were rational numbers because they're based on ratios. So if we look at all the numbers that we use today, they fall into groups, but they aren't separate groups. There's a lot of overlap. So it's helpful to look at a diagram. Okay, one of the biggest groups is what we call the rational numbers. This includes any number that can be expressed as a ratio of 2 integers. Now that includes numbers like integers, because we can put them over 1 to express them as rational numbers. So the integers are all rational numbers, but rational numbers includes many numbers that are not integers also. Now within the integers, we also have the whole numbers. So if a number is a whole number, it's also an integer, and it's also a rational number. Now recently we've started talking about a separate group of numbers that doesn't belong to any of those groups. These are not rational numbers, so they're called irrational numbers. Irrational numbers are non-terminating and non-repeating decimals. And if you look at all of these groups, they actually belong to one big group of numbers that we call the real numbers. So any of the numbers in any of these groups is also a real number. When you're asked to classify numbers, you should always list all of the groups that they belong to, starting with the most specific. So in this case, I have a list of numbers and we're going to classify all of them. The number 2 is a whole number, and because it's a whole number, it's also an integer, and it's rational because it can be written 2 over 1, and it's also a real number. How about -13? Well, that's an integer, so it's also rational and real. 0.75 can also be written as 3/4, so that's a rational number, which is also a real number. And 2/3 is also a rational number. How about a repeating decimal like 0.55555 forever? It turns out that all repeating decimals can be written as fractions. This one's equal to 5/9 exactly. So it's a rational number. So repeating decimals are rational numbers, and they're rational and real both. Okay, 14/7's kind of a trick question. This is equal to 2 if you reduce it, so actually it's a whole number, which is also an integer and rational and real. 2 pi. Well, pi is irrational because it is a decimal number that is non-terminating and non-repeating. Any multiple of pi is also irrational, so that goes here. -(25). The square root of 25 is 5, so this is equal to -5, which is an integer. So we will put that here. And because it's an integer, it's also rational and real. The next one simplifies also. Square root of 9 is 3, so this is like 3/7, which is a rational number. Remember, I'm putting them in the most specific label that they have, but they all have more than one label. So 3/7 is rational, but it's also real. And finally, we have square root of 10. When you take square roots of numbers, there's only 2 possibilities here. If this is a perfect square, it can simplify. But if it isn't a perfect square, all we can do is approximate that into a messy decimal. And so that is irrational and also real. And that gives you an idea of how to classify numbers. Just be sure that you start with the most specific label and include all the labels it belongs to. And a diagram like this really helps.